December 25th, 2021. Most of you might remember that as Christmas Day, whether you celebrate it or not. To me, it was one of the most memorable days of my life. It was already remarkable that, being an astronomer, I was awake at 4:30 in the morning, watching and live tweeting about the launch event of the James Webb Space Telescope, also known as the JWST. But the best was yet to come at 6 a.m. when my water broke, 2.5 weeks ahead of my due date, and my daughter was born. Oh. Yes. She was very cute, and she's gotten up big and curious and chatty now, asking questions, lots and lots of questions, including recently that dreaded one, "Mommy, where did I come from?" Folks, where do you start? So I told her that she spent months growing in my belly until this one Christmas morning when the most amazing telescope, the JWST, was launching, that she decided to arrive. But she pressed me. But where do babies really come from? So I ummed and ulled, and finally I caved. From stardust. And she seemed content, at least for now. But really, that's the truth. She's stardust. She's made of stardust. And so are you, and so am I. And there's a long history of how we got from the stars to where we are today. And we're now beginning to figure it all out. I used to tell people that astronomy as a science is like celestial archaeology. Just like how a fish or a plant leaves an imprint in the ground when it dies, a galaxy leaves a light imprint in the sky over its lifetime. And when we're looking back at that light in the sky, we're actually looking back in time. And so studying galaxies is like digging up fossils in the heavens and finding breadcrumbs as clues to how our universe has gotten from the Big Bang 14 billion years ago to today. And we've learned that galaxies have lives too. They form, they grow, and they age. They're not just some static, inanimate objects for us to admire from a distance. No, they are dynamic entities that are actively forming stars, birthing and recycling elements that are important to life. In the stellar nursery, where stars are born, hydrogen gets compressed to form stars. And as the star grows through a process called nucleosynthesis, that hydrogen converts into helium and other heavier elements like carbon, oxygen, and iron. And at the end of its lifetime, the star explodes, sending all these elements back into space, enriching the environments for the next generation of stars, planets, and of life. And that's why we're deemed stardust. We're literally recycled stars in our galaxy. So we've learned that galaxies are full of life. In fact, we call them cosmic ecosystems, with moving parts like the stars, the origin of stardust, of us, and importantly, the galaxy's heart, the supermassive black hole. It turns out that the supermassive black hole plays a role in regulating the galaxy's growth and governing its fate. And we're now using JWST to figure out what that role is. So this is the story that I'll be sharing with you today, filling in those early missing chapters of where babies come from in all the glorious pictures. We'll start in the 1920s here in Los Angeles at Mount Wilson Observatory's 100-inch telescope. It was the state-of-the-art, the largest optical telescope around at the time. And it was here that astronomer Edwin Hubble looked through that telescope and discovered that there were galaxies outside of our Milky Way. These are the pictures he took 100 years ago, each one an image of a galaxy that's external to our own. And similar to how Copernicus discovered that the the Earth rotates around the sun, disrupting the belief that the Earth was in the center of the universe, Hubble's discovery was one of those pivotal moments in the history of humankind. We realized that we were just one of many, many, many galaxies in the universe. His work created an area of study that focuses on phenomena outside of our Milky Way, and that's what I do. I'm an extragalactic observational astronomer. I study galaxies outside of our Milky Way. This is an image that JWST took of the deep skies. Nearly every single blob you can see on this image is a galaxy outside of our own. And they come in different colors, shapes, and sizes. Now, I won't have time to tell you how the first galaxies formed. I wasn't given 14 billion years to tell that story. But I will say that many of these galaxies have grown through merging. Now, here on Earth, mergers and acquisition happen all the time in the business sector. In cosmic history, smaller galaxies merge to form larger galaxies. And they consequently form with other galaxies to form even larger galaxies. So over time, all these merging events lead to the massive galaxies like our Milky Way today. And just exactly how does this galaxy merging happen? Here is a video that shows the dance that two galaxies do as they merge with one another. Now, what I'm showing you here, this is computer simulation, but it is interleaved with real images taken by the Hubble Space Telescope in visible light. And as this whole merging sequence takes place over the course of 1 billion years or two, we're quite thankful that simulations such as this exist to let us visualize how this merger sequence actually plays out. And so you can see in the video that, when Dada Galaxy and Mama Galaxy, they first meet, and they go on a first date, and then they pass each other by, come back for a second date, and do this delicate dance until they fall in love and become inseparable. And together, they form a larger galaxy. As for the black holes that sit inside these galaxies, we believe that they merge as well, but that is still an active area of study that we're actually researching. So black holes are fascinating phenomena. They represent the dark unknown. They are the densest objects in the universe, packing a whole lot of mass into a very tiny space. And despite having names like supermassive black holes, the black hole that sits in the center of a galaxy is tiny compared to the size of the galaxy that they reside in. So for instance, if I were to shrink the entire Milky Way down to the size of our Earth, the Milky Way's central supermassive black hole would shrink to the size of tip of a pencil. And yet, if an object were to fall towards the tremendous gravitational force of the supermassive black hole, there's no escape. Nothing can escape, not even light. And if a poor astronaut finds himself near one, they would get spaghettified. So why should we care about black holes? Well, I've mentioned that they are integral to the life of a galaxy. And since we live in a galaxy, understanding how black holes impact a galaxy is relevant. We've learned that black holes act like the heart of a galaxy, governing its birth, growth, maturation, and death. Black holes actively eat up the gas and dust that's surrounding them. And at the same time, energy is released. And when I say energy, I mean a force so tremendous that it blows out gas in powerful winds, forming stars and stardust, the very makeup of you and me. And it's this circle of life that's analogous to blood being circulated into the heart and being pumped back out, supplying oxygen to the rest of the body. So being a celestial heart surgeon, so to speak, I'm happy to show you some of the pictures of my galaxy patients. And until now, our view of the black hole regions have been quite limited. Now here is galaxy merger VV114 seen through the Hubble Space Telescope in visible light. And you can see that in the center of that left side galaxy, the region is relatively dark, and that's because the light is hidden behind the dust particles. When we shift into the infrared, the Spitzer infrared telescope showed us that actually, yes, there is a lot of light coming from that black hole region, but the resolution is quite coarse. And it wasn't until now that JWST shows us an amazingly clear view of what goes on in that black hole region. And so you can see from these images that JWST allows us to see the light through the dust. And we can see directly how black holes are influencing the birth of stars, gas, dust in the galaxies, and very likely life. So when we think about where babies come from, where we come from, JWST is our path to discovering our evolutionary journey from stardust to humanity. Scientific ingenuity and JWST will help us write those early chapters of how we came to be. Chapters that will make the story of where babies come from all the more magical. There is so much more to learn about the origin of our existence. And there is so much more to see in the great beyond. The sky is not the limit. Thank you.